Now that we know how to find a paired t-interval by hand, we're going to take those ideas and apply them to a problem where a lot of the heavy lifting's been done for us by a computer program, but we're going to have to apply what we know and see if we can figure some stuff out. So you have the U.S. Census Bureau publishes information on the ages of married couples. Suppose we want to determine whether in the U.S. the mean age of married men differs from the mean age of their wives. Okay, well, notice I highlighted the husbands and wives thing, because if they're husbands and wives, that means you're dealing with a paired test, like where the sample is dependent. Just not that it's important to know now because it's kind of obvious because of the section we're working in. But when you're getting to your test, that's how you're going to determine whether you're looking at one kind of test or another. All right, so we have a random sample and they created this confidence interval. And I changed this question a little bit from one semester to the next. I made it verify the requirements needed to construct an interval were met. And notice, hint, they're the same as for a paired t-test. So let's go look at the paired t-test for a second. On a matched pairs t-test, you have to have a simple random sample of size n. You have to have a normal distribution or n greater than 30, or you have to have n less than or equal to 0.05 capital N. Capital N being the population size. These same requirements were required both for a paired t-test and for a regular t-test. They're also required for any t-interval you want to make, a paired t-interval and a regular t-interval that we've already learned in Chapter 9. They all both require the same thing, which is you have to have a simple random sample, you have to have less than 5% of your population in your sample, and you have to have normal distribution or n greater than 30. So I'm going to use that information and verify our requirements. So do we have a simple random sample? Absolutely we do. It says right here that it's a simple random sample, so it's given to us right there. So yes, we've got that. Do we have n greater than 30? Well, no, we don't. It's a little bit jumping the gun, but we actually have n equals 10. But it's okay that n is 10 because we know from the graph that the distribution is normal. So it's okay. We need to know that it's normal or that it's bigger than 30. We know the normal part because of the graph right here. Then we need to know, is little n, sample size, less than 5% of capital N? Well, obviously, right? I mean, little n is the number of married couples, or capital N, excuse me, the number of married couples in the world, right? So little n equals 10 is far less, far less than 5% of all the married couples in the world, right? That's a huge number. All right, now I kind of, again, jumped the gun a little bit, but n equals 10, and you know that because your degrees of freedom is 9 right here. Since your degrees of freedom is 9, you know that n must be 10 because degrees of freedom is n minus 1. And just to make sure it's really clear where that came from, I'm going to put a little orange box around the degrees of freedom in the output so you can see it. All right, now we want to estimate the point estimate for the difference. Now, if you remember, the point estimate
you guys
is
are in exile tomorrow if you don't win tomorrow's challenge. If you win tomorrow's challenge, you'll be receiving a pardon, and you can pick any of these other teams to take your place in exile.
Total shocker, honestly.
Okay.
Derek and I are just, we're just going to take care of each other.
All right, now
you know,
how do we find
we're going to send each other home. This is the last thing I was
3.6, but
I need
how do I
Theo
get
and Shonda
that?
and Derek and
Well,
Dean
remember,
back in the hall.
it's the center of your interval.
And the rest of you
So
guys
what you
have
need to do is you
20
need to
minutes
take
to
your
determine
lower
who's going to be
limit
facing them
plus
in
your
exile
upper limit
right
and
now.
divide by 2 because you need to have the average of the two of them. So 0.0439 plus 7.156, add them up and divide by 2.
Backstab Tina, or
and
I
you'll
can
get
do what is
the middle. So let me find that. So 0.0439 plus 7.156, add them up. Oh, 1561, sorry. I forgot about the rounding on that one. 1561, right? Because that 5 will round that 0 up. I should have done that. All right, sorry about that. So 7.1561. So 0.0439 plus 7.1561. There we go. We divide that by 2, and we get 3.6. There we have it. That's your center of your interval. Oops. All right. So So don't forget that the point estimate is in the middle of that confidence interval for either a z interval or a t interval. All right, now we're supposed to compute the margin of error. When I drew this picture down here so you could see it, but the error is the distance from the right-hand edge to the center, or from the center to the left-hand edge, or if you like, it's half the width. All right, so I'm going to copy and paste in here and then put in the new numbers. So we've got the upper edge is 7.151, 7.1561. Yeah, 1561 minus the lower edge, oops, I missed my 7 there, minus the lower edge of 0.0439. That's 4 decimal places. That should be good. All right, so I need to find that distance right there. So 7.1561 minus 0.0439 gives us this number, and then we're going to cut it in half. So that'll be 3.566 for 5561. And that's what I typed up right here. So half of the high number, 7.1561, minus the low number, take that subtraction, then divide it in half. That'll give you 3.5561 is the distance from the center to the edges. You could also find it by subtracting the upper edge minus the center. Since you know d bar in the middle is 3.6, you could take 7.1561, take away 3.6, and you should have 3.5561. Or similarly, you could take the middle, 3.6, and take away the low number. It should be the same thing. All right, now does this confidence interval suggest that there is a significant difference? All right, there are those words again, significant difference between husbands and wives. All right, well, what wouldn't be a significant difference? If they're not significantly different from each other, that would mean that 0 is in that interval, right? That null hypothesis equals 0 is always standard through all of chapter 11. If there's no difference between the groups, no difference implies when you subtract them, you get 0. But 0 is not in our confidence interval. 0 is just outside of it. The lower edge of our confidence interval is 0.0439. 0 is not in there. That would imply that there is a significant difference because 0 is not in that interval. So I'll type that up. I'll be right back. There we go. If there was no difference between men and women, or I should say between husbands and wives, right? Between no difference in ages, between, sorry, my hands are on the wrong keyboard there, in ages between husbands and wives, and their wives, I should say. It wouldn't be, it doesn't really mean much if it's somebody else who you're not married to at all, right? Then that would mean that there are 2 of them are equal to each other. And that means when you subtract, you're going to get 0, right? If they're equal, if one's 40 and the other's 40, you subtract, you get 0. But our confidence interval does not contain 0. The lowest number we have is 0.04. 0 is not in our interval. That implies that there is a significant difference in ages between husbands and their wives, or between wives and their husbands. I'm gonna reverse it just for the heck of it, not to be all sexist about it. Between wives and their husbands. There we go. All right, we're all done with section 11.2 for paired differences, and then we're going to move on next to independent samples. I know I'm doing this chapter a little bit out of order, so I'm doing 11.2 first, then we'll do 11.3, which is about means as well, but it's when their samples are independent. So husbands and wives that aren't married to each other, for example. All right, we'll see you then.